myself is Divya Bahal, Assistant Professor in Chemical Engineering Department at LJIET Institute of Engineering and Technology. The subject that I am going to take is petroleum refining and petrochemicals. So in last lecture we saw about gaseous fuels, okay? What are the different types of gaseous fuels and its important properties, okay? Now moving forward, we are going to study about gasoline, okay? So in this chapter, what is the prime motive is to know about the properties, its uses and the different tests, okay? Starting with gasoline, okay? So this is the volatile fraction which is obtained after gases, and its boiling ranges from 37 degrees Celsius to 180 degrees Celsius, okay? So the gasoline, okay, this fraction, it has the minimum range up to minimum boiling point is 37 degrees Celsius to 180 degrees Celsius also, okay? That is the range of this fraction. It is the finished product whose raw form is called as naphtha. So as we discussed earlier also, from distillation column, you get initially different fractions, okay? So this is the naphtha, okay? Naphtha is a fraction which after some treatment, okay, modifying it, it is converted into gasoline, okay? So gasoline, as I told you, you can tell that it is a brand name, okay? So which is obtained, okay, from naphtha. The raw form gasoline is called as naphtha. Now, refinery. So refinery produces up to 40 types of gasoline, okay? And of course, it is 90% of it is used in automobile industry. The petrol, diesel, whatever we use, petrol, okay, it is gasoline itself. So it is mainly used as an automobile fuel, okay? Now, of course, available as leaded and unleaded. We will study further in its different tests. Why is the need to make it leaded and unleaded, okay? Why is the addition of lead done into the gasoline? Now, a petroleum distillate coming straight from an atmospheric distillation unit without being cracked or reformed. What is it? It is called as light straight run naphtha. Okay, it is a form of gasoline, LSR naphtha. Okay, it is a fraction which you obtain from distillation unit. Okay, from the name itself. Okay, straight run. From the distillation unit itself, the first fraction which you obtain, that is your light straight run naphtha. Okay, it is often blended directly into gasoline, okay? It is used as blend, okay? Now, you will study it further. Now, it's the major composition of light straight run naphtha is the normal paraffins, okay? So, the gasoline which you sell in the market, it is a blend. It is a blend of what? Paraffin, aromatics, okay? Different other additives also. So, it is used as a blend, okay, in gasoline. Now, what are the properties of it? It has low octane number and relatively high vapor pressure. High vapor pressure, it means it is very fast boiling, okay? It boils very fast. The initial boiling point is very low of it, okay? It is very volatile. Now, to boost its octane number, it is often sent to other units, okay? Where isomerization, such kind of units it is sent, okay? Reforming section. It is sent to those reformates so as to improve its quality. You can see, okay, directly from this example, that your crude which is subjected to distillation, okay, what you get is a straight run naphtha. Now, how your straight run naphtha is, further divided, okay, the naphtha splitter, you get light naphtha, which is directly sent to the gasoline pool. Then you have heavy naphtha, okay, it is now sent to reformers to improve its quality, okay, that way it is done. Now, focusing on the naphtha splitter. See, naphtha, as we discussed, it is having low carbon chain, okay, normal paraffins are there. So up to C5, whatever carbon you're having, okay, up to C5 to some C8 carbon level, whatever you're getting, that is naphtha, the raw form naphtha. So the light naphtha, hard cut naphtha, okay, the middle and heavy naphtha, okay. Different naphthas have different uses, okay. Some are used directly as a blend into the gasoline, okay. Your finished form is the gasoline. Now to improve to make another kind of blend, as we discussed about 40 types of gasoline are there, okay. Some are directly added into the finished form of gasoline, okay. Some are sent to the reformates unit to improve its further characteristics. So that way, your whole naphtha is sent to the different units, okay. Like a light naphtha, it is sent to isomerization unit, hydrogen generation unit, okay. The hard cut naphtha, It is used. It is sent to the catalytic reforming unit. Can also be used as a blend. Okay. Heavy naphtha is again sent for catalytic reforming. So you can see the different cuts of naphtha which are used in different various other units. So now why we can't directly use the light straight run naphtha as an automobile fuel? See, because its properties are that way. Now, this type of fuel does not have qualities that are suitable for that of automobile fuel. Okay, because of that, it is blended with other kind of gasolines. Okay, so because it is blended into other kinds of gasoline, so we can divide now our gasolines in different forms. So what are the types of processed gasoline? Okay, from light straight run naphtha, we are making gasoline. Okay, so because we are having different kinds of blend, okay, we are sending this naphtha into different kinds of units for improving its quality. Okay, so now we get different kinds of gasoline. Okay, based on the processing units we send the naphtha, we get different types of gasoline. So what are the different types of gasoline? Okay, processed gasoline: reformate gasoline, alkylated gasoline, polymerized gasoline, cracked gasoline, coked gasoline, hydrocracking gasoline. See the uh, different kind of reactions which are involved. You can see alkylation, polymerization, cracking, coking, hydrocracking. Okay, you will study all these processes in another chapter. Okay, when we are concerned with the treatment of crude oil. Okay, when we are interested in treatment processes. So I'm sending my naphtha into different units. Okay, as we saw, like we sent light naphtha into isomerization unit. So the gasoline which I obtained from that is now my isomerized gasoline. Okay. Similarly, I sent some of my like heavy naphtha was sent to cracking unit. Okay, so that gasoline which I got is cracked gasoline. So that way, based on different processing, I get different categories of my gasoline. Now, what are the tests for gasoline? Okay, we have certain tests like ASTM distillation test. Okay, it is kind of test we are doing. It is to know the boiling characteristic of the gasoline. Okay, as we discussed earlier also, about 40 types of gasolines are there. Okay, so each category will have a different characteristic. So these are the tests which we do. Okay, to know certain properties. Like ASTM is done to know the boiling. Heat vapor pressure is to know about the volatility. Octane number to know the quality. Antenna property. Okay, you will study it further. What is octane number? Then gum content. What does gum content show? It shows about the oxidation stability of your fuel. Then sulfur content, of course, it is associated with corrosion and pollution problem. So starting with the ASTM distillation. Now what is ASTM distillation? See, it is a lab-based distillation. We discussed this in distillation characteristics also as a part of fluidless analysis. So it is a simple distillation which is carried out using lab apparatus. Okay. What here we are doing is, in a distillation flask, I am taking my sample of gasoline. Okay. Then I am heating the mixture. More volatile component will start to vaporize. The vapors are further condensed and you get your distillate. Okay. This is the simple distillation setup which we have done. Now, observation table. So, of course, a practical is done. So, we are going to note down some observations also. So, see, this was discussed earlier also. So, what you do in ASTM, okay, the amount of sample is very small, okay, from 100 ml to 500 ml only, so your experiment is done. So, what here I am taking my basis as 100 ml. So, the first drop of distillate which I will get, that is your initial boiling point, okay. We discussed that definition of initial boiling point at first chapter also, in first chapter also, that it is the minimum temperature at which your first drop of the distillate which you will get. Okay, so that is your initial boiling point. So what here we do, we record the temperature of several volume percent distilled up to final boiling point. Okay, as my mixture is now heating, more and more vapors are formed. Okay, so distillate will also be obtained. Okay, continuously I'll get distillate. So what I'm doing is I'm making I'm collecting the data of temperature to the corresponding percent volume distilled. Okay, for example, at every 5 ml of my distillate collected, I'm noting down the temperature. So I can say because my basis is 100 ml, so 5 ml distillate I am taking into account, so that would constitute as 5% distillate, 5% volume distillate. Okay, I am taking my data for every 5 ml of distillate. So at every, I can say that every 5% volume distillate, I am taking the measurement of temperature now. So how I will get my data? So you can see 0 to 95%. Okay, see volume percent distillate, 0%, 5%, 10%. So corresponding to that I am taking the notations of temperature. For example, when my 5% of distillate was collected, what was the corresponding temperature? So till when I have to do this experiment, till final boiling point. Okay, so I will get a table and observation data for volume percent distilled and the corresponding temperature. Now plotting this graphically, temperature for the graph is my now temperature versus percent volume distilled. Okay, see, temperature versus volume distilled. So now plotting this data, I get my results as follows. Okay, starting from the initial boiling point to final boiling point, I can relate that how the change in volume percent, okay, with change in volume of distillate I am getting, how the temperature is varying here. So that we study in ASTM distillation. Okay, this plot shows the boiling characteristics of your gasoline. You can see the first red dot here. Okay, it is near 54 degrees Celsius. We saw in the observation table also at 0 ml. Okay, first drop, we can take that it is almost 0%. So that temperature was your initial boiling point when you get your first drop. Until when I have done my data, the last, you can see the red dot, that is the final boiling point. Okay, yes. So till final boiling point, I'm doing the data, I'm collecting the data and I'm plotting it. Okay, so what does it show for different volume percent distillate? Okay, for different, like up to 10% distillate, that is having very high amount of volatile component. Okay, so that kind of distillate will have certain characteristics. Similarly, if I'm moving further, so talking about 90% distillate, now in 90% distillate, less volatile component is increasing. Okay, it is in majority. So the characteristics will be different. So what this graph help us is to know about the boiling characteristics, to know about the properties which we can relate with that percentage of distillate. So we can say from the observation that ASTM distillation specifies evaporation characteristics of gasoline. Okay, now you can see how. See, refinery has to regulate the blend based on the climate. Okay, if cold, if I'm talking about winter, in winter what I need, I want my gasoline, my petrol to have high vapor pressure. Okay, it must burn easily. Okay, it must be easily be able to burn. Okay, it must form flammable mixture very early. So I need low IVP. It means initial boiling point must be low for that kind of fuel. Means I have to increase the amount of more volatile component in my gasoline blend. Okay, then only ignition will be fast in cold climate. Whereas in summer, we don't need high vapor pressure. Okay, in summer I don't need my fuel to vaporize very early because in summer already temperature is high. Okay, if I'm in the blend, if I'm adding very much volatile component to very high limit, then there will be chances of losses also. Okay, so characteristics like flash point, vapor pressure, ease of starting, etc. can be known from this analysis. Okay, taking example, suppose for 10% volume distillate, okay, for 10% volume distillate I have to know like how this ASTM distillation plot will help me. 10% volume distillate means the distillate. Okay, when 10% volume was collected, so what would be the characteristic of that distillate? It would be high in volatile matter. Okay, because it is 10%, it would be very near to initial boiling point. Okay, it is very high in volatile matter. It has low flash point. Okay, what is flash point? See, it is the minimum temperature when your fuel can catch fire. So low flash point means it can very easily catch fire at very low temperature. It has very high vapor pressure. See, boiling point is related to vapor pressure. Okay, High vapor pressure means low boiling point. It is boiling very early. Low vapor pressure means high boiling point. Okay, the temperature has to be very much so as to able to boil. Then excellent ease of starting. So see, 10% volume distillate. What are the characteristics? These are the characteristics. Okay. Now, other tests are like octane number, gum content, sulfur content. Okay, these would be studied in next lecture. Thank you.